and we'll see if we can have some fun with it. So again, we're gonna watch this video. I want you, while we watch the video, if you would, just write down the information given. If you miss something, don't panic. I actually have all the information here, but I just need to warn you, this video is not the best of quality. The cameraman really had a hard time. I was the cameraman. I was the cameraman and also the person who had to measure the braking distance. The other math teacher, he just had to ride his motorcycle and tell me how fast he was going and hit his brakes. So I'm going to switch over to this video. Let's see if it works for us. Actually, let's cancel. I'll go here real quick. Let's see, did it share? No, didn't share. I want to go here and share. Would somebody verify if there's a video that showed up? It looks like just.
Yeah.
Okay, cool.
Yep.
So I think you can hear. So all I need you to do during this video, and again, it's 5 minutes. I might skip forward a little bit because it's pretty brutal, and I don't want to subject y'all to that. But write down the braking distances that are talked. We're going to write them down as ordered pairs. So if the person said on the motorcycle said he was doing 15, that would be an X. And if I measured it and it came out to 25 feet, that would be the Y. Does that make sense? All right. Really bad video. Please let me know if you can't hear it.
Today we're going to be watching some braking distances. We have the motorcycle's not moving. How far is the braking distance? That's 0, guys.
So write down 0, 0.
0. So here we go. We're going to measure the time, walk some distances.
So 6, comma.
We're at 1 foot 5 inches. 1 foot 5 inches.
So 1 foot 5 inches. Write that down.
How fast are we going? That was 9 miles an hour. 9 miles per hour. Here's my hands dragging. 4 feet 11 inches.
4 feet 11 inches at 9 miles an hour.
$19 miles an hour. 19 miles an hour, 18 feet, exactly.
19 miles an hour, 18 feet.
fast are you going? That was 40. I can't remember now. We might have to redo that. Okay, possibly 30 at 44 feet 9 inches.
It is 30 miles an hour at 44 feet 9 inches. So 30.
We're trying this one again. That was 32 miles an hour. 32 miles an hour. We're at 52 feet and 1 inch. That other one must have been 30. Okay, the other one must have been 30. Okay, let's turn it out. How fast are you going? 40 miles an hour. 40 miles an hour. 84 feet exactly. How fast? That's 48, and I'm almost out of gas. 48 miles an hour at 110 feet, 4 inches.
All right, I told you it was kind of brutal footage, not professionals, but does everyone get the basic gist of what we were doing, of how we collected that data?
Yeah.
Yeah.
Okay, so so the first piece of data we have is 0 miles per hour, 0 feet, 0, 0. And then the next one was at 6 miles per hour, which was 1 foot 5 inches. Now I'm going to convert 5 inches into a decimal. So I'd go 5 divided by 12, and you go 5 over divided by 12, you wind up with 0.42. So at 6 miles an hour, the motorcycle stopped in 1.42 feet. Does that make sense? And again, I was just converting inches into a decimal. The next piece of data is 9 miles an hour, and it did it in 4 feet 11 inches. So let's convert 11 inches into a decimal, which I'll go 11 divided by 12. 11 divided by 12 is 0.92 roughly. So at 9 miles an hour, you have 4.92. At 19 miles an hour, we don't have to convert anything because it stopped at 18 feet. At 30 miles an hour, it stopped at 44 feet 9 inches. If we convert 9 inches into a decimal, that'd be 9 divided by 12, which is 0.75. So at 30 miles an hour, you did 44.75 feet to stop. And then at 32 miles an hour, that stopped at 52 feet 1 inch. Convert 1 inch into a decimal, so you go 1 divided by 12, that gives you 0.08 roughly. So that 32 miles an hour, you have 52.08 feet. Then at 40 miles an hour, you stopped at exactly 84 feet. And then at 48 miles an hour, you stopped at 110 feet 4 inches. So we convert 4 inches into a decimal. 4 divided by 12 is 0.33. So that becomes 48, 110.33. Does everybody feel comfortable so far with what we talked about?
Yes.
All right. Thank you.
Yeah.
All right. So the next thing we're going to do is we are going to go into Desmos, and I have to get over into Desmos on my computer, and I'll share my screen. So I think most of you have used Desmos before. It's just desmos.com, and then you get to a screen that says, let's learn together. You don't have to to join this or anything like that, you can just go to it and you hit graphing calculator. And did a XY axis pop up for you all?
Yeah.
Yeah.
Okay, cool. So on Desmos, we have to know where to enter our data into tables. And I'm going to put our braking, our miles per hour and our braking distance in here. So I'm going to hit the plus, and we're going to go down to the table. And it's going to give us this. And we can just plug in our data, 0, 0, 6, 1.42, 9, 4.92, 19 is an 18, 30 was at 44.75, 32 was at 52.08, let's see what else we have. That's 32. 40 is at 84. And 48, I told you we broke the speed limit in the parking lot, was 110.33. Okay. So I'm going to move this. All right. So if you look on Desmos, you can start seeing some points that show up. And let me go to, I'm going to go to projector mode to make it a little darker. So if I start zooming out, we can start seeing our data. Does everyone see the data that's plotted?
Yeah.
Okay. So then we need to figure out the line of best fit that's going to work, and you have to program it into Desmos a little bit. So notice our Y1 is labeled at Y sub 1, or X1 is labeled as X sub 1. So you go down, you create a new graph, and we're going to do this. We're going to go Y1, and it automatically sublets it for you. And then you use tilde, so that's a shift next to the 1, A, and then X sub 1, again, it already subscripts it for you, minus H, close the parentheses, make sure you raise that because it's a parabola, plus K. So it's in vertex form, but notice it creates you this parabola. Now the information on the left side of our parabola, we're not doing negative miles per hour, but here's kind of the cool thing about this. So can everyone see the equation down here where you have A, H, and K?
Yeah.
Okay, so that means that our parabola equation, and I'll talk about what R squared means in a second, our parabola equation is Y equals 0.044868, parentheses, X plus, it's going to be plus because I have to plug a negative value in, 2.39419, close parentheses, square it, and then we're going to subtract the K value, which is 1.12632. Okay, so I'm going to move this to I'm not worried about anything beyond, I'm not worried about things that are negative numbers because we're not doing negative miles per hour. This R squared value basically means, in layman's terms, not official math terms, Desmos is 99.74% sure this is the parabola that works. So if you got a 99.74% on a test, you'd probably be pretty okay with it. You wouldn't be like, what partial amount did I not get? Maybe you would, I don't know. But this is a really good line of best fit. It's a parabola. Now, some few things that Desmos is going to do for us. I'm going to move this over. Give me a mile per hour. Let's face it, let's have some fun. It was a fast motorcycle. How fast do you think that motorcycle could ride?
Like 110.
110? Okay. So if I type X equals 110, I have a vertical line that shows up, and I have to kind of, take Desmos, and I'm going to zoom out. And there definitely looks to be a spot. So at 110 miles per hour, that motorcycle would take 565.6 feet to stop, more than a football field. Okay. So that's kind of a valuable tool where it's like, oh, well, now we had data, and this is called extrapolating data because we're outside of our data. If we had a piece of data that was inside of it, that would be called interpolating. But so like, let's say we want to interpolate something. So inside of our data here, let's say 25 miles per hour. Okay, so if I go x equals 25, then we have this blue line. We come here. That means that our motorcycle stops at 25 miles an hour. It would take 32.543 feet to stop. Now, write that down for me, please. Write 25, comma 32.5. And you know that's 25 miles per hour, and 32.5 feet is the braking distance. Okay, let's go 1 mile an hour faster. So x equals 26. And let's write this down. 26 miles per hour. With our model, with this motorcycle, we're talking about 35.0 feet. So you're talking about 2.5 more feet it takes this motorcycle to stop. 1 mile an hour. Now think about what the average speed in a neighborhood would be. It should be 25 miles an hour. What's the difference between 2.5 feet? What difference does that make? And I would tell you this, and this is a little bit, think about like community service wise, how you could state this. 2.5 feet means you narrowly missed the child versus the child is under your car, or in this case, under the motorcycle. I mean, that a lot of people say, oh, what's the big deal? 1 mile per hour. Think about what 2.5 feet really is. You're a half foot shorter than a yard. Okay, so it does mean something. Now, other things that this could do, and this was, let's say this person was speeding on their motorcycle, and the police officer saw them hit their brakes really hard and come to a stop. So they're going to find their initial hit of their brakes, because there will be a mark on the pavement, even though it's anti-lock brakes. There's an initial skid mark, and they could measure the distance. But let's say they said, you were going pretty fast. Well, how fast was I going? Well, it took you 650 feet to stop. Okay, so we're going to have a horizontal line here. So then that police officer, or the guy says, 650 feet? Okay, yeah. What is that, like 30 miles an hour? It's like, no, sir, you're doing 118 miles an hour. So think about what that kind of means in the context of how this could be applied to a real life situation. Okay, and it kind of works out kind of fun. So I want to give you 3 minutes, and I'm going to try something. I want to go to a breakout room. I want to see if this works. I've never used this before. This is my first time. So I'm going to put you into some breakout rooms, talk with each other for 3 minutes, and then I'll bring you all back in, okay? Just talk about how you would convey this as a public service message. Ready? Let's see if this works. Breakout rooms. There's 25 of us, 6 in a room. Create breakout rooms. Open all rooms, so it should switch you to a breakout room now. Cora and Anna, did you go to a breakout room?
The whatchamacallit thing, how it could be applied. Well, I mean,
my breakout room didn't work. Could you try to send it to me again, please? You're muted.
Can you hear me now?
Yeah.
All right, let's see which breakout room. Did it a little icon show up for you?
Yeah, but then there was like no one in there, and then it kind of just like.
Okay. I'm going to hit. I'm going to put you in breakout room 3.
Okay.
So it should work for you now.
Okay. Nothing is showing up. How do I? Oh, wait. I think. Oh, okay. I got it. Thank you.
Uh-huh.
It's always like more awkward to talk in Zoom calls than it is in real life for some reason.
I
And
agree.
it's just like, what the heck? I don't even know.
Well, it's just awkward to like keep your camera on the whole time too, because like
Exactly.
no one else has their camera on, so it's just like.
Ten seconds it shows on their breakout room, so they should all be coming back. Thank you for those of you who came back already. Okay, so what did you discover with each other? What did you find out? Someone want to share? 10 seconds.
Well, like me and my group was just kind of thinking about like doing something where it's like the difference between like maybe like 10 and 15 miles an hour, or like showing how every mile an hour like that you add, how like much longer it takes, and like how that can be like effective on a person. So that's what we were kind of thinking.
Cool. Somebody else from a different group.
You kind of said the same thing as Andrew did, but we kind of added that like the faster you go, the longer it takes to slow down. So it's harder to like be aware of your surroundings that way.
Absolutely. One more group. Go ahead. Nobody else? In 3, 2, 1. Okay. So this is a real life application. This braking distance is indeed a parabola. There are other variables that take into account if what kind of road it is, what kind of weather conditions, whether it's dusty, whether it's wet, icy, snowy. There's all kinds of different things, but no matter what it's going to go on to, you can determine braking distance based on just running some data, and seeing this should work out. So one, I appreciate y'all coming. I hope this was not horrible. I will put in some points for my kids. I don't know what Mr. Padovic's promising his kids, but I thank you for just going to the breakout rooms. I did chime into a couple of breakout rooms just to see what it was like, because I'd never used it before. But I think it's pretty valuable. I think that you got some good stuff out of this. So if you have anything for me, let me know. If not, get out of here. Have a great day. Take care of one another. Bye-bye.
Thank you, Mr. Stirrup.
Thank you. Have a nice day.
Thank you.
Bye, guys.
Thank you.
Stirrup.
Yeah.
What video? What videos? I think it was the